In this video, we're going to look at just basically how to use the distance formula. And so we're going to begin assuming you kind of already have a foundation of where this formula comes from and why it works. It's derived from the Pythagorean theorem. This video is not going to go into that, but it's going to just go into how to use it. So we have 2 points shown here. We have 3, 8, and 9, 10. And I intentionally, on this first, just want to use all positives so we can see kind of really easily how these numbers fit into the formula and how to use the formula. In our next example, we'll use some negatives because it's really easy to make sign errors here. So let's just say I call my first point x1, y1, and let's say I call my second point x2 and y2. Doesn't really matter which one you call which. I could call this x1, y1 and this x2, y2, and you'll get the same answer as long as you don't make any sign errors. So as I come over here, I guess I can just kind of work this problem over here right under my formula. X2 minus x1, here's my x2, here's my x1. So we have 9 minus 3 squared plus, and now we're going to do y2 minus y1, 10 minus 8 squared, and don't forget that radical. And so now let's just simplify each of these values that's being squared. So that 9 minus 3 is going to become 6 squared. That 10 minus 8 is going to become 2 squared. And so now we can to turn 6 squared into a 36 and 2 squared into a 4, which is the square root of 40. And that square root of 40 can be simplified a couple of different ways. One is it looks like that would simplify as a radical to 2 square roots of 10. Or if we want to do a decimal approximation in our calculator, that would become roughly 6.32. So any of these answers for me would work. This would probably be your best answer here in the middle. I'm not going to, in this video, go from how to get from the square root of 40 to 2 roots of 10. That's a process called simplifying radicals. If you're not sure how to do that, maybe watch a different video for that. But let's look at another example. Let's look at one with some negatives in there so we can kind of be careful with our signs. So in this example, we got 2 points. Once we're finding the distance from here to here. And so let's just label our points x1, y1, and x2, y2. It's really a straightforward process, but because it is, there's always a lot of like simple error mistakes. That's why I always label my points as x1, y1, x2, y2, and then I'm real careful with my signs over here. So let's kind of start our process. I'm going to start with doing x2 minus x1. I want to talk about that. x2 is negative 4 minus x1, which is negative 5. So that's what we have, and that whole value is being squared. So I can kind of show this. There's my minus sign, and then the x2 and the x1 are kind of shown in red there. Let's kind of keep that going. So I'll kind of do the same thing over here. Oops. And then we have y2 minus y1. So that would be y2 minus y1. And then we don't want to forget to take the square root of the whole thing. Now let's be real careful with our signs in here. Here, if I have negative 4 and I'm subtracting a negative 5, that means you're really adding 5. So that becomes negative 4 plus 5, or in other words, 1 squared, plus negative 6 minus 0 is negative 6 squared. And now we can just simplify. 1 squared is 1. Negative 6 times negative 6 is positive 36. So this becomes the root of 37. I believe 37 is prime, so that radical is not going to simplify. But if we wanted to get the decimal approximation in our calculator, that would be roughly, not exactly, but roughly 6.08 units away. That's how far this point is from this point on the coordinate plane. So just one thing to emphasize, these are pretty simple problems, but I would always encourage you to label your points x1, y1, x2, y2, and then copy down your formula and fill in the blank and take it step by step. Simplify a little bit every time. These are not difficult problems, so you don't want to miss them due to a simple error.